Myself Dr. Abhas Kango, Electronics and Communication Department, Kite Group of Institution, Ghaziabad. In last lecture, we are going to see about the pressure measurement. In that, we have seen what are different types of pressure, like what is absolute pressure, what is gauge pressure, what is vacuum pressure, also what is static pressure, what is dynamic pressure, or what is the head pressure. In that, we have seen the some type of devices that can be measured to pressure, or that can be able to measure the pressure, and we are seeing about the manometer. So, we will continue the last lecture, and in that lecture I have told you about the various pressure measurement method. In that, first we are reading about the manometers, then we are having the Weld gauges and the pressure measurement using elastic element. In last lecture, we are continuing about the manometers, and we have seen one type of manometer that can be called as a U-tube manometer. So, the what is the basic definition of manometer, that I have told you in last class also, that a pressure due to liquid balance by pressure produced by a column of a liquid of known density, that will be called as a manometer, and that will work on the formula that will be that P is equal to rho g h. Okay. Now, next category is the Weld gauges that we will see after the manometer that has been complete. We in this lecture we are going to see two more types of manometer, that will consider Weld type manometer and the inclined type manometer. Then we will switch over to the Weld gauges, and then the pressure measurement using elastic elements. In the last lecture also, we have seen the classification chart of the pressure transducer. So, in that chart we are seeing about the manometers. So, it can be used to measure the simple manometer, that can consider the category of U-tube manometer, that will work on the formula that P is equal to rho g h, or the differential pressure measurement in that category, that will include the U-tube differential manometer or the inverted U-tube differential manometer, and these are certain mechanical gauges that will consider the Weld gauges, also the elastic gauges. So, that will include the mechanical gauges. So, that will be formed in the two categories that we have studied in last class also. Now, in this lecture, our first topic is, we have seen the what is the working of U-tube manometer in the last lecture. In this lecture, we will see about the Weld type manometer. So, the basic principle is difference, because Weld type manometer can be used to measure the differential pressure. So, we will see that what is Weld type manometer. So, this type of manometer is a advantageous than U-tube manometer. How, that we will see one by one. So, one reading of single liquid level in single vertical leg is needed rather than two readings of height in both columns. So, how it is advantageous, we can understand from this line, that one reading of single liquid level in single vertical leg is needed rather than two readings of height in the both the columns. So, we need to see only the reading of single vertical leg. So, that will be the advantageous as compared to U-tube type manometer. Now, we will see some more characteristics or working of Weld type manometer. So, it is sometimes called a single column gauge, because we need to understand only the single vertical leg leading. So, that will be the sometimes called the single column gauge. So, the Weld type manometer also can be called as a single column gauge. Also, we will move ahead, that the manometer consists of metal well of large cross sectional area connected to a glass tube or limb. And I also told you what are the various liquids that can be used in the manometer. So, preferably in Weld type manometer, we will use the mercury as the filling liquid, and when we talk about the construction of Weld type manometer, we can see that the manometer consists of metal well of large cross sectional area and that will be connected to the glass tube or limb. So, we will see now this is the basic diagram of the Weld type manometer. In that diagram you can see over that we are having two part, we are having one vertical column and this column that will be the well shaped. So, that is why a one column or one part of the Weld type manometer is in the form of well, that is why it is called as a Weld type manometer. So, in that you can see that pressure is to be measured is applied over here. So, firstly the height of the liquid is this, the height of the, you can see over here, firstly the height of the liquid is this from the ground, but when we applied the pressure then this height becomes this only. So, basically the height of the liquid in that column is will be equal to the h, but when we applied the pressure that height will become h plus x. So, that is the basic principle that we need to follow in Weld type manometer. So, basically it will work on the principle that P is equal to rho g h. So, when we have applied the two pressure over here. So, what will be differential pressure, that will be P 1 minus P 2, that will be equal to rho g, and after applying the pressure the height become changed. So, height will be now h plus x. So, that will be the basic formula that will be followed in Weld type manometer, and by using this formula we can measure the value of pressure. So, that will be the basic working of Weld type manometer. Now, by you can see over here that working is explained in this also, I have already told you in the diagram. So, you can read this, that in Weld type manometer the pressure to be measured is normally applied to the well. You can see in the diagram that pressure has been applied into the well which is to be measured. Okay. And when the pressure is applied to the well, the level of liquid in the well falls by the distance x and the level in the limb rises by the distance h. When I will apply the pressure over here, there will be the rises in the this column because of the applied pressure. So, now the present height is h, but after applying the pressure the height will become h plus x, that I have already told you. Also, when the column of liquid h plus x exerts a pressure equal to the pressure applied to the well, the liquid stops moving. Now, after moving, if a liquid stops moving, the value of h plus x will increase as the pressure to be measured increases and will decrease as the pressure to be measured decreases. So, it will vary with respect to the pressure which we need to measure. Also, the scale is normally calibrated in units of pressure mm of Hg or in the Pascal. So, basic I have already told you in the previous lecture that the basic unit of pressure which we use is the Pascal or Newton per meter square, that will basically follow. So, from that device we can directly read the unit of pressure in terms of Pascal or Newton per meter square or in mm of Hg. So, that will be the basic working of Weld type manometer. Now, on the same path the inclined type or inclined tube manometer works. So, basically the inclined limb manometer is the manometer in that limb is inclined at an angle to the horizontal. So, the limb will be inclined or the second column will be inclined like that, that will be make some angle to the other one. The basic working is same like Weld type manometer. So, the effect of inclining the limb is to make the manometer more sensitive than the Weld type. So, the sensitivity of Weld type manometer is less as compared to the inclined type manometer. So, to increase the sensitivity of Weld type manometer, we have used the inclined type manometer. The working will be the same, but the sensitivity will be increased by this inclined tube that or the inclined limb that we are going to use in the Weld type or the inclined type manometer. So, the effect of inclining the limb is to make the manometer more sensitive than the Weld type manometer, that will be allowing the more accurate measurement of a lower range of pressure. So, that will be the big advantage of inclined tube type manometer, that can read the value of raw pressure or we can use for low ranges of pressure as compared to the Weld type manometer. So, I already told you that principle will be same as Weld type manometer. Now, we will see with the help of diagram that what is the what is the working with respect to the diagram given. So, that well will be same that we have used in the Weld type manometer, but the other limb or the other tube that will be different, that will be inclined on some angle, that angle is equivalent to the theta. Now, in that we can see that will be inclined over the theta and that height is equivalent to y and that length is equivalent to t. That length is important because we need to calculate this angle. So, that has been considered, that will be equivalent to small d, and when the pressure that has to be measured, that will be equivalent to P1, that has been applied over here, then the length will be changed or the water will be changes by the length x. So, that will be the working will be same, that will be work on the formula P is equal to rho g h, in that the pressure which is to be measured, that will be called as the head pressure and that will work on this formula, that P is equal to rho g h, that we have seen already in the previous lecture as well as in this lecture. So, rho is the density, g is the gravitational constant and h is the height of liquid column. In that, from this scale we can read out the readings. So, in that case, after applying pressure, what will be this equation? That will be equal to P1 minus P2, that will be equivalent to rho, that will be density, g is the gravitational constant, and what will be the height? That will be equal to x plus y in this case. So, by using this formula we can measure the value of the pressure, that is the pressure that has to be measured. This is our well, this is having area A1, this is our inclined tube, the length is d, that has been used because we need to calculate on which angle it is inclined. So, the basic formula from which we can calculate the pressure that can be measured, that will be equal to P1 minus P2 is equal to rho g into x plus y. So, that will be the basic working or the basic principle of inclined type manometer that will be advantageous as compared to Weld type manometer, because inclined tube that has been used here, which will be provide you the more you can accurately measure the low pressure, as well as it will be sensitive. So, sensitivity is the one characteristics of instrumentation. So, it will become good in the case of inclined type manometer as compared to the Weld type manometer. Now, we have seen the three types of manometer. In that we have seen most simplest type, U-tube type manometer. In that we need to read out the both the sides, both the scales. Then we have seen the one more advantageous manometer like Weld type manometer. So, in that we need to read only the single vertical leg. So, that will be advantageous as compared to the U-tube type manometer. Then we have seen the inclined type manometer, that will be advantageous as compared to the Weld type manometer in terms of sensitivity and the ranges of the low pressure. So, now we can see the various advantages of manometer collectively. So, what are the various advantages of manometer? Firstly, it has very low cost. Second is, the manometer is suitable for low pressure applications. Also, it is simple in construction, as we have seen all category of manometers. So, the construction is very simple. Also, it has better sensitivity and it has good accuracy and it has simple operation and the construction. So, these are the certain advantages of manometer, that will be the collective advantages that includes all category of manometer that we have seen. So, in that we have seen the Weld type manometer, inclined type manometer and the U-tube shape manometer. So, these are the certain collective advantages of manometer. Now, also there are certain disadvantages of manometer. So, first disadvantage of manometer is it is large in size and bulky, that means the installation is difficult. It needs leveling, because it can be the pressure is with reference to the differential pressure we also need to measure. So, the pressure applied and the pressure rise, that should be very accurate. So, that is why it needs the leveling. Also, the no fixed reference is available. Also, in manometer the error is introduced due to the condensation. So, the condensation will produce the maybe the source of error in case of manometer. Also, it has no over range protection. When the over range followed, it has no over range protection. Next, the manometer has poor dynamic response. So, dynamic response is one of the main characteristics of instrumentation that we have seen in the previous lectures. So, that will be the one disadvantages of manometer, that the manometer has a poor dynamic response. Now, next category of pressure sensor are the mechanical pressure sensor. So, we have divided the pressure measurement in two categories. One is manometer and second one is mechanical pressure gauges. Second one is mechanical pressure gauges. So, we have seen about the manometer, what are various types of manometers and what are the different classification of manometer. The second category of pressure sensor is the mechanical pressure sensors, and that includes both the categories, wet gauges as well as elastic pressure measurement. So, when we talk about the pressure measurement or the mechanical pressure gauges, that will include both category of measurement, that will include the wet gauges, also that will include the elastic pressure gauges. elastic pressure gauges. So, in that we can see that the first 4 will be the type of elastic pressure gauges and the last 3 will be the type of wet gauges. So, we are going to see that one by one. So, this will be all about the mechanical pressure sensor and we need to understand all those types of mechanical pressure sensors that will includes the diaphragms, capsule, Bourdon tube, bellows that will come under the category of elastic pressure sensor and that all 3 will be comes under the category of wet gauges. So, we are going to see it one by one. So, the first category is the diaphragm. So, when an elastic transducer, a diaphragm is an elastic transducer because I have already told you that it is a type of elastic pressure measurement or the elastic pressure transducer. So, what basically the diaphragm is, when an elastic transducer in this subjected to a pressure, it deflects, this deflection is proportional to the applied pressure when calibrated. So, the simple working of diaphragm or simple principle of diaphragm is, when we applied the pressure, we will got the deflection that will be proportional to the applied pressure. So, that will be the basic principle of diaphragm. The main parts of diaphragm, which is thin circular plate that will be made by them some springy metal or that will be fixed firmly around its edges. The diaphragm may either be flat or corrugated. So, we are going to see the type of diagram in the diagram that will be seen later. So, basically a corrugated diaphragm that has been shown in the figure that we are going to see, in that the displacement of the diaphragm is magnified the mechanical means. A flat diaphragm has been shown where the displacement of the diaphragm is sensed by the secondary transducer such as parallel plate capacitor. So, firstly we are going to see, or we have to see the what is the elastic diaphragm gauge. So, the basic definition I have already told you. Then when we applied the pressure, we will get the deflection. When we applied the pressure, we will get the deflection that will be proportional to the pressure applied. That will be the basic principle of diaphragm gauges, or basically more precisely the elastic diaphragm gauges. So, in that we can see over here in the diagram, a pressure has to be applied, is to be applied from here, and that will be our isolated diaphragm. So, with respect to that diaphragm, we have got the displacement of reading from this scale or from this Bourdon tube. So, that will be that you can see over that one dial is there, that will be on certain position, the dial will be on certain position, and when the pressure is applied, the from the applied pressure or with respect to the applied pressure, we can get deflection in the needle. So, the position of needle change and the position of needle change, that will be proportional to the applied pressure. So, that will be the simple working of the elastic diaphragm gauge. So, in that the working has been explained, that I have already told you that the top portion of the diaphragm is fixed with a boss of negligible weight. Also, this boss is in turn connected to a link sector, that will be the pinion arrangement. Also, the pointer is connected to the pinion, which makes the sweep over the pressure calibrated scale. So, pointer will be moved according to the applied pressure, and if the displacement is sensed by the secondary transducer, then that can be changed into the electric output. Now, the next category of pressure gauge is the Bourdon tube pressure gauge. So, that will be the working of Bourdon tube pressure gauge is like the diaphragm gauge, like we have seen. So, in that this is the C type Bourdon tube, in that the applied pressure is over here, and basically firstly our pointer will be some fixed position, like this is our pointer, and that will be connected to the Bourdon tube. Now, in that we can see when the pressure is applied, that pointer will be deflected with respect to the applied pressure. So, that will be proportional to the applied pressure. So, that will be the simple working of the Bourdon tube. That arrangement can be used, and that will be the primary transducer, that will comes under the category of primary transducer. So, that will be the basic working of Bourdon tube. There are various types of Bourdon tube that are available. So, we have seen the working of C type Bourdon tube. Likewise, helical Bourdon tube is also available, and the spiral Bourdon tube is also available, and the working will be same like C type Bourdon tube, helical Bourdon tube and spiral Bourdon tube. The shape will be different, the basic principle and the working will be same. So, that all comes under the category of primary transducer, that can be connected to some secondary transducer to make the electric output. So, we will see more precisely in the next lecture. Thank you.